Welcome and thanks for joining us today. At Zivid, we help our customers build better and more capable robot cells. Last year, we introduced the Zivid 2+R, setting a new benchmark for small and mid-sized workloads, such as piece picking, bin picking, and parcel handling. Today, we're introducing an entirely new 3D camera from Zivid, designed specifically for the bigger and heavier workloads that forms the backbone of today's industrial automation. Workloads like depalletization in warehouses and picking heavy items from large bins in factories. This is a well-established segment with several proven solutions already in the market. Yet, we kept hearing from customers that current cameras were holding them back, limiting the capability, performance, and reliability of their robot cells. So we decided to take on that challenge, and this is Zivid 3. Stick with us, we'll walk you through what's new, how it helped you build better and more capable robot cells, and share a few real-world examples from our lead customers. Let's get started. Øyvind, thanks for joining me. You've been key in this development from day one. Can you talk a little bit about the challenges we set out to solve with the Zivid 3?
Yeah, we see that the industry is demanding a lot of depalletizing, and these robots, they need to handle a bigger variety of pallets and totes. So we see a lot of mixed SKU depalletizing going on now, where a single pallet can contain a ton of different items, all sort of chaotically packed together. It could be boxes and cans and plastic bottles and magazines and you name it. And this trend, it brings some big challenges from a vision perspective. So one, you need to be able to basically see every item that's on the pallet at all times. And from a 3D and the robot perspective, this is quite hard. You need to be quite precise so that the robot don't bump into things and topple things over and create damage. Actually, despite what many might think, depalletizing is a quite accuracy-demanding application. You're trying to move these tightly stacked and very heavy objects safely over long distances and as fast as possible. When you're operating at these scales, even very small calibration errors within the camera will cause large errors for the robot. So in order to prevent it from making mispicks and creating damage, you need a very accurate camera. These calibration errors can be quite common when you have a lot of temperature variations, and that's very normal in depalletizing and so on, where you're operating next to a loading dock, where a door can be opened, there could be a draft and seasonal changes. So with Zivid 3 XL250, we aimed at addressing these challenges and really raising the bar for 2D and 3D sensing in depalletizing. So we wanted to make a camera that could let the robot see everything on the pallet, whether it's transparent plastics or black tapes and whatever, and also work reliably when it's dark or bright. And we wanted to make the camera very accurate and really, really thermally stable. And then, of course, depalletizing, palletizing, truck unloading, all those applications, they're very time critical. So you want to maximize the time you spend on the road and basically do all the unloading and loading as quickly as possible. So in order to make that possible, we wanted to give our customers a really fast camera so that they can push the limits of their pick rates.
Thanks. I think that really captures it. Now let's talk a little bit about the camera itself. What are some key features and specification that stands out to you?
So this is a 8-megapixel camera that can capture both 2D color images and point clouds together in less than half a second. It deals really well with very difficult materials and very strong ambient light. It's optimized to operate from about 1.5 meters to 4 meters away. So we really designed it for these 2-meter tall pallets that you find in the US and Asia. And for some applications, you can use it even further away. And the point cloud trueness of this camera is really good, so that you can perform picking with millimeters of accuracy. Throughout the conception of this camera, we've been very fortunate to work with some really good lead customers that have given us input and feedback on sort of how to make the best out of this camera. So what we're going to do now is we're going to head over to Japan, where we've been working together with Mujin, and they're going to show us how they put this camera to the test and what they could do with it.
When we first started working with robot vision, we knew there were limits to what our existing camera systems could do. Point cloud noise and accuracy in presenting the real world influence the recall and accuracy of detecting the items to be handled. This directly impacts the robot system performance. By addressing point cloud noise and accuracy, the robot system performance increases over time. This reduced downtime and the number of interventions. This allowed the customer to process orders more reliably and expand their factory capabilities. When our vision engineering team started their search, we were focused on a few critical features. We needed more accurate point cloud to allow the robot to handle items successfully and without damaging them. Furthermore, reduced point cloud noise ensured that a larger variety of situations and items could be detected confidently, reducing human interventions. We actually found those features in this new camera. It allows us to detect items within a few millimeters and allowed us to handle items successfully without fail, pushing the boundary beyond 99.9% performance.
The reason we decided to adopt Zivid cameras wasn't simply because we wanted new features. We wanted to fundamentally improve stability and ease of implementation on site. One of Zivid's strongest points is their presets, since they offer a very good starting point for finding a stable configuration for our applications. We can tackle a wider range of use cases, different lighting conditions, workpieces, etc., and it critically reduced the time we spent on initial setup. Another big advantage is how user-friendly the intrinsic calibration procedure is. It only takes a few minutes to complete, and it offers real-time trueness and accuracy data while taking snapshots, so it's easy to understand that it is going well. Once intrinsic calibration is done, it can remain stable for a very long time under a variety of harsh conditions. Plus, point cloud quality is exceptional. In my personal experience as an integration engineer at Mujin, the applications I work with require a high level of accuracy in detection results. Otherwise, my peak process won't be stable enough to satisfy customer requirements. Zivid cameras excel not only in performance, but also in ease of use. The setup is simple, and integration into multiple projects is smooth and efficient. As a result, our engineering team's workload has decreased, and for our customers, that means faster implementation and a clear reduction in total project cost. This reliability out of the box is a tremendous value.
So, what does this mean now for Mujin and our customers? By solving problems we couldn't solve before, we're not just keeping up, we're leading. And that's exactly what we want, to push the boundaries of automation and make sure our customers stay ahead with us.
We talked quite a lot about depalletization. In your mind, what are some other applications where Zivid 3 fits and add value?
This camera is exceptional for factory bin picking, when you pick from large bins. So you can think like a cubic meter big crate, like Euro pallet size. Even at these big field of views, this camera delivers less than 0.25% of dimension trueness. So it's very, very accurate. It deals with very black and very shiny materials really well, and also really strong ambient light, so that you can really pick with a lot of precision. On the other hand, we've been spending quite a bit of time in e-commerce over the past couple of years, and there we've seen a lot of these big cardboard boxes that are filled with products packed in plastic. For those kind of applications where you're picking, for example, fashion items, you need a camera that has really high speed. It can give 2D and can give 3D and see transparent parts. You kind of need a camera a little bit like Zivid 2+R, just bigger. So you need a camera like Zivid 3.
Great stuff, Øyvind. Wrapping up this chat, what's next?
Next, we have the camera team with us. They've been working hard to make this product, and they're going to dig a bit deeper into how it works and show us what it can do. Hi, Ariel. You're the general behind the camera team that's been making this camera and testing it to its limits. Could you tell us a little bit more about what's inside and your process in creating it?
Sure, I'm very happy to be here. First of all, I would like to say that we have successfully built the Zivid 2+R, and we took all the good things from 2+R into the Zivid 3 product. That means that you still are able to capture all the complex parts from shiny metal to transparent parts, but now at a longer distance and wider field of view. And this product is the pure stationary product, the first pure stationary product we have made, and it's ideal for your use cases. I will explain what I mean by showing some point clouds. So here you can see point clouds from a warehouse. You have cans, you have plastic bottles wrapped into plastic, you have boxes, you have bubble wraps, everything that is common in a warehouse. Since you know that it might be very bright in some places in the warehouse, we have taken this point cloud with a lot of light. And see how well the Zivid 3 camera can be able to capture all these objects with very good coverage. Let's look at something in the details here. So look at the six-pack of bottles with the wrapped plastic and the good coverage that we have on this. Good coverage is essential to figure out where to put the suction cup from the robot. And this object is very heavy, so if you are not able to find the center of gravity, you might have a mispick. Another important factor here is dynamic range. We'll demonstrate that by looking at these white boxes. It has a black tape on it, and you see how well we are able to capture the black tape and the white light box itself. If you are not able to have data on this black tape, the tape might fool you to think it's two boxes instead of one, and you might grab it in the corner and not in the center of the box. In depalletizing, it's important to see and separate boxes from each other, and gap detection is often used for that. So see how well we are able to detect these very thin gaps between those white boxes. Pretty amazing. This camera provides very good color at different distances and different ambient light. We also made this camera thermal stable to avoid any mispicks and destroy any items on the pallet.
Ariel, that was a really nice demo for what this camera can do in warehouses. What about factories?
I have a point cloud of typically common objects in the factory. Here you can see metal parts. You have, I think we have an electrical charger there. You have a black shiny car mirror, and you have some suspension, very complicated suspension arms there. And in this use case, it's absolutely necessary to have accurate point cloud in different temperature variations and with the different light conditions. And look at the small metal brackets there, how well we are able to capture the details despite the internal reflection we have from them. Look at the small holes and the cylindrical shape that we are able to capture. In this use case, it's common to use CAD detection. And in CAD detection, it's important to have very accurate shapes and edges. If you look at the suspension arm, that's a very complicated part. So you can see that we have been able to capture all the edges very well, and we have the shape. It's important because when you try to match the point cloud with the CAD, you need to have perfect match. If not, you will have a mispick or you are not able to find the item. One of the most complex parts to capture is when the object is both shiny and black. But look at how well we are able to capture this car side mirror. Looking at the curvatures and the shapes that we're able to create, And finally, here is a picture of a car hood, which is painted in black. And see how well we're able to capture these bumps and the holes and how clear the edges are on this part.
It looks amazing. That's super impressive, Arild. So can you talk a little bit about how the camera is able to do this?
Sure. First of all, we have stepped up on resolution up to 8 megapixels, as you said earlier. And this is basically to have a sufficient resolution throughout and the entire working distance. We also made the image square, so it perfectly fits to US and APAC palettes, which is the largest palettes used. And this camera is also optimized for stationary mount far away, right? And if you have longer distances, it's more challenging to keep the accuracy. To tackle that, we have increased the baseline and ruggedized all the optics. We have developed sophisticated calibration techniques and made the camera resistant to environmental impact like temperature variations, shock and vibration. And the results that we get out of this is pretty amazing. Now we are able to handle high resolution and down to 0.1% trueness error. Basically, that means that you can point this camera to everything in your factory and capture high resolution with just a few millimeter of tolerances. Also, this camera provides both 2D images and 3D point glass using the same sensor. And that makes it easier to combine 2D and 3D algorithms without any mapping error when you are transferring between pixels and points. And as the 3D camera is factory calibrated, so is the 2D camera. So it will give brilliant color and sharp images.
So what was the biggest challenge in making this camera?
Well, this is the most powerful camera we ever made. And this is to make a camera that can work at longer distances with a lot of light and wider field of view. So we had to increase the light output from this camera up to about 5 times. But at the same time, we were able to keep it eye safe and thermally stable. And we are very proud that we have been able to solve that.
Fantastic, Arild. Thank you very much.
You're welcome.
That was a good walkthrough. Next up, we're going to talk to Audun, who will explain to us how this camera was designed and how we built reliability into it. Welcome, Audun.
Hi.
So this camera obviously looks quite different from what we made before. Can you tell us a little bit about the design here?
Yes, of course. So with Zivid 3, we wanted to design something that is both robust and elegant. Obviously, it's a much larger product, and this is because of the increased baseline that we need for the optical precision. We made this product for stationary applications, and we didn't prioritize making it compact and lightweight. Instead, we focused on durability and robustness. You might think that the large cover glass in front is fragile, but this glass is 20 times stronger than normal glass, and we did a lot of impact testing to check this. So we know it can handle some serious abuse. Just look at what the test team is doing to it. On the back side, we have the ventilation system. It's the same efficient cooling solution as before, but now the air doesn't have to be pulled in from the front, in front of the lenses. We have the ruggedized M12 connectors, and everything is protected by this protruding frame. We removed the LEDs from the back side, and we put them on top instead. And this is for the user to be able to see them, even though the product is mounted high above the scene. On the inside, we have done everything possible to make sure that the optical system remains unaffected, no matter what happens on the outside. And we have done a lot of very violent mechanical tests to check this. Even after vibration and shock testing, we don't see more than 0.02% change in trueness. So Zivid 3 is a camera you can trust in demanding environments without us compromising on the sleek and professional design that we are known for.
This is a precision instrument, right? And it's really important that the calibration stays accurate, not only from vibration and temperatures and shock and so on while it's running, but also while it's being shipped around and installed and so on. So how do you think that this camera is going to fare when you ship it around the world?
Oh, this camera will survive pretty rough handling during transportation, and it will even survive a small drop to the floor.
Really?
You want to give it a shot?
Okay, why not?
Okay, hold this for a minute. Okay.
All right, are you sure?
I'm sure.
Okay, well.
Let's try this.
Yeah.
Ready?
Yeah, ready. Let's go. Okay, that didn't feel good at all. Okay, that was pretty nerve-wracking. Do you think it still works?
I think it's good.
It looks good.
It does.
So I guess we should try it out then. Let's bring it up to Sam and see if it still works.
Are you guys dropping cameras again?
You're right, Sam. We just dropped this camera. Can you check if it still works for us?
Still looks new. Let's mount this bad boy.
All right, so let's see what you got.
Okay, but before we get started, let me paint you a picture of what the challenge has been with the Zivid 3. And that challenge has been to cover these large pallet-sized field of views from very long working ranges. So if you think about depalletization robots, they're typically really big, and they have to operate on these really tall pallets. They have to be able to move the boxes out of the way without running into the camera. So we're talking about 1.5 to 4 meters and beyond in terms of working range to get the right clearance. Now, large distances and structured light, they don't really mesh pretty well. That's because when we project light onto the scene, by the time it gets back to the camera, it drops off like the square of the working distance. And if you think about a typical structured light camera, it works in the range of 0.5 meter to 1.5 meters. If you took that same hardware and you stretch the camera out to 4 meters, that point cloud is going to suffer. It's probably not going to be a very good looking point cloud, and it's going to take a long time to get the capture. Ambient light makes everything worse. So when we have depalletization, it's very common that, for instance, it's near a loading dock where a lot of sunlight can come in, and then that could destroy your point cloud as well. So you have these two things, ambient light, large distances. That degrades point clouds, gives you really long capture times. So if you want to solve depalletization right, you have to push structured light to its boundaries. We did this in 2 ways. We completely revamped the projector. So now it projects nearly 5 times as much light as our previous models. And then for the camera, we've introduced a new ambient light reduction mechanism that helps get rid of pesky external light sources while keeping a crisp 2D color image. Even though the projector produces so much more light, it's under 100 watts, the total system. So we have the same power requirements of the 2 Plus and 2 Plus R. That keeps the system thermally stable as well. But the real achievement we have with the Zivid 3 is that it gives you really nice point clouds across a really large working distance. And so that means that we're really bringing the robot arm to these tall and wide pallets.
That sounds very convincing, Sam. But let's see it in action now.
Yeah, that's no problem. Let's get right into it. So we have it connected here. Remember, it's the one that you guys dropped. So let's just take a 2D plus 3D capture here. And I just want to point out a few of the objects. So we have this really shiny black car piece. It's the back of the side view mirror. We also have these plastic bottles here, wrapped in plastic. And we have some shiny metal parts. And we have assorted cardboard boxes. And what I want to show is just how good of coverage we get on these black shiny parts here. The full mirror, backside of the mirror is covered. We have really good shape trueness on these metal objects, even though they're nice and shiny. We're even capturing this transparent plastic on top of the bottles. And then look at this. We get the gap of the cardboard, even though we have a huge stack of boxes right next to it. So I want to point out that even though we doubled the baseline from the 2 Plus R series, it's still a much smaller baseline than a lot of other structured light cameras that do depalletization. So that allows you to not have projector shadow and capture these objects even when there's very tall objects next to it. But what's really interesting about this point cloud is that we get this quality even though we're greater than 4 meters away from this pallet. Well, I'm going to surprise you even further. If you look up, we have a glass ceiling. So we have all of this ambient light shining on the scene. We're 4.5 meters away from the pallet here, as well as you drop the camera. This is kind of crazy. I would not recommend this. But even though we have a ton of light and we're really far away, this point cloud is crushing it. So I want to crank this up a notch. Let's push this baby a little bit past the spec sheet. So I'm going to angle this guy up. Nice. So we have this thing pointing out a little bit farther out into the bottom floor. So we're going to have a lot larger field of view, and we're going to have a lot longer working distance. Let's make a capture. Oh, we got some friends down there. So you can see here that we have we've angled away from our pallet. We can see now a lot farther down on the first floor. If we look at the 3D data, we have out in the corners all the way out to 7.3 meters. And then these tables here, they're around 6 meters. And let me just show you here. Those are black, shiny tables, black, shiny plastic. And we capture them really well. And you can also see that we capture the people down there. This is way past 4 meters. This is not what this camera is designed for, but still it's able to handle this point cloud quite well. So this really shows you the power of our new hardware and how much light we really packed into this baby.
Thank you, Sam. That was a fantastic demonstration of how this new Zivid 3 camera works in a real-life environment, especially with the glass ceiling and everything. That was really fantastic.
Yeah, no problem, Øyvind.
That kind of concludes the demos here. And we now talked a lot to our engineers. We've seen how this camera is built, and yeah, Sam just showed us how it works in real life. And next thing that we're going to do is we're going to head over to our friends in Poland, No Magic, and see what they did with this camera in the fashion industry.
So, hello everyone from the lab of No Magic. Today with me, Philip.
Hello, great meeting you.
Thank you for having me. The head of engineering of No Magic. Two relatively questions for you.
Go ahead.
First of all, can you tell us a little bit more about the collaboration between Zivid and No Magic? Because we're gonna talk about vision, cameras, and robots.
Absolutely. So when we started working on more advanced placing use cases, we did quite deep market research at the time. We checked most of big players, most of new players, and of course Zivid was one of the companies that we started talking to. And we quickly realized that the product that they offer meets all the requirements that we have, very high quality and very easy to set up. And at the same time, we noticed that the team culture fits perfectly what we would expect. So moving quickly, delivering very high quality, reacting to feedback that we have, and working together towards the success of the customer project.
That makes sense. So let's say it was just a fit. It's just a great fit. So, Enor, sorry for sticking my nose, but I've noticed something. The new camera probably is the new Zivid 3. Can you tell us a little bit more? What's the intention of using it here? What's the application?
Absolutely, of course. As you see behind us, we have a slightly bigger robot and a slightly bigger source container, so the carton box behind us. All of this to allow the robot to have bigger distances, pick more items during the same process, but it also means that we need to have a camera that works at those working distances. Regular camera didn't work for us so well, so when we learned that Zivid is working on the new version, so Zivid 3, we checked that it will meet all the requirements that we have. We signed up for the tester program. And it met all the promises that we had. So far it's working very, very well, and we are in the process of integrating it.
Let's keep it like this. So guys, we always say that, by cameras we are giving the eyes to the robots. So I bet that with this one, we are just giving the eyes on steroids. Thanks so much and much success.
Thank you.
So this is Zivid 3. The first Zivid camera designed for the bigger and heavier robotic workloads. With a working distance from about 1.5 to 4 meters, covering a volume large enough to handle a fully packed US pallet, it is ideally suited for applications like depalletization and big bin picking. It delivers 3 things that truly set it apart. First, it enables the big robot to handle more challenging items. Transparent, shiny, glossy, dark or light, tightly packed or small, and to do it reliably from the top of the pallet to the bottom, even under strong or changing ambient light. Second, it delivers higher and more reliable pick success rate, minimizing missed picks, drops, and damages, even over time as the cell runs day after day through temperature changes, shock, and vibration. Third, it does all of this at high speed, keeping up with the robot, not limiting the cycle time, and enabling the robot to work faster and increase productivity. It's the result of years of heavy engineering and a close collaboration with our lead customers who pushed us to raise the bar once again. I'm incredibly proud of what the team has achieved and deeply grateful to our lead customers, Mugen and No Magic, for their trust, collaboration, and feedback throughout this journey. Full specs and point cloud examples available on our webpage. Book a live demo with our team. Zivid 3 is available to order today, on stock and ready to ship. We are excited to see how you will put Zivid 3 to work. And on behalf of everyone at Zivid, thank you for joining today.